So this is one of the strangest, most concerning, most exciting predicaments that humans have ever been in. This idea that we have bad intuition for language model intelligence. We're treating language models as if they were humans. Now, I'm going to try and unpack three things here. The first thing is that, we're treating language models like humans. This is a mistake. Second thing is, if you develop better intuition for working with language models and understanding how they think, not like humans, then you're going to get way better results. You're going to have way better synergy working with language models in this new form of intelligence. And the third is just to unpack some evidence to suggest that modeling the model, understanding how the models think and work, is a skill that is distinct and separate from raw human intelligence. And increasingly, it's going to be more important. So this is a really good tweet. They're always great tweets from Karpathy. He basically explains here that we have bad intuition. We have this bad intuition because animal intelligence has been shaped over hundreds of thousands or millions of years of evolution. We die, we're going to die. We have social constraints and constructs, all of these things. Language models don't go through the same evolutionary process, so they're different intelligence. Doesn't matter what you think about if the language models are really modeling the world or if it's real intelligence, the process was different. But it's fucking confusing, right? Because the models are RL'd, they're trained, they're reinforced to produce coherent text and become chatbots. And this triggers all of our human senses. So we think that they're like humans and we develop poor intuitions for how they work and then we interact with them poorly. He says something at the end here which kind of sums this up, which is really interesting. People who build good internal models of this new intelligent entity will be better equipped to reason about it today and predict features of it in the future. People who don't will be stuck thinking about it incorrectly like an animal. I'm going to play a 1-minute clip from the Dwarkesh pod where he unpacks this idea.
I mean, if a human was put in a similar situation, had to be trained from scratch. Well, I mean, this is like a human growing up or an animal growing up. Yep. So why shouldn't that be the vision for AI rather than like this thing where we're doing millions of years of training?
I think that's a really good question. And I think, so Sutton was on your podcast and I saw the podcast and I had a write-up about that podcast almost that gets into a little bit of how I see things. And I kind of feel like I'm very careful to make analogies to animals because they came about by a very different optimization process. Animals are evolved and they actually come with a huge amount of hardware that's built in. And when, for example, my example in the post was the zebra gets born and a few minutes later it's running around and following its mother. That's an extremely complicated thing to do. Yeah. That's not reinforcement learning. That's something that's baked in. And evolution obviously has some way of encoding the weights of our neural nets in ATCGs. And I have no idea how that works, but it apparently works. So I kind of feel like brains just came from a very different process. And I'm very hesitant to take inspiration from it because we're not actually running that process. So in my post, I kind of said, we're not actually building animals. We're building ghosts or spirits or whatever people want to call it. Because we're not doing training by evolution. We're doing training by basically imitation of humans and the data that they've put on the internet. And so you end up with these like sort of ethereal spirit entities because they're fully digital and they're kind of like mimicking humans. And it's a different kind of intelligence. Like if you imagine a space of intelligences, we're starting off at a different point almost. We're not really building animals, but I think it's also possible to make them a bit more animal-like over time. And I think we should be doing that. And so I kind of feel like, I guess one more point I do feel like.
Okay, so this paper, Quantifying Human AI Synergy, this is interesting and it's related. It basically shows that modeling the model, having a good theory of mind, understanding this different form of intelligence, it leads to better synergy and output, obviously. More interestingly, it shows that the skill of understanding how the model thinks and how the model works is different from being smart. It's different from raw human intelligence. So the ability to model the model is a distinct skill that predicts better outcomes. So I'm interested in this, and I think everybody should be interested in this because it seems logical and slightly concerning, very concerning actually, that understanding how models work will become increasingly more important than being smart. And the two will increasingly decouple. So let's look at the paper. This is obviously a triggering idea for some people. I'll do my best to explain the TLDR of the paper, and then we can dig back into what it means to have a better model of the models. So essentially, we have okay ability to understand and model human intelligence or to measure human intelligence. We have benchmarks. It's a bit of a circus, but we have benchmarks and ways of measuring model intelligence. But there's not much work that's gone into human plus AI intelligence. So that's what this paper did. It took 700-ish participants, and they give the participants a bunch of questions to answer without the help of AI. The questions were around math, physics, moral reasoning. So solo ability, and then they allow the same participants to answer the same questions with the help of AI. And what they found here, this is my way of unpacking the results here. Say you have two people. Both people are equally intelligent, okay? And the scores on the solo when I say solo, I just mean when they answer the questions without the help of AI, they're equal in intelligence, equal score. But in many cases, one of those individuals was far better when answering the questions with the help of AI, which suggests there's a difference here, a difference in collaborative ability, a difference in being able to model the model and work with AI. So the end result, or the part that I found most interesting, was this idea that raw intelligence, raw human intelligence, raw problem-solving ability does not equate to better results. Actually being able to understand the model, have a better perspective of how the model thinks and works, was a stronger indicator of the results. So this is a graph, this is a table from the paper. Basically on the left side here, we have the ability of individuals to, so all the dots basically represent the participants. The left side is the ability of the individual to solve problems by themselves. And then the right is the ability to solve problems with the help of AI. So x-axis is theory of mind. It's a single score consistent between the two charts. So they were given a score for how well they were able to model the model. And then you can see the difference. So on the left side, there's more or less no statistically meaningful correlation there, meaning that if the human has good theory of mind, it doesn't make a difference to how well they answer the questions by themselves, right? But on the right side, you see where they're now using AI, the humans with a high TOM, theory of mind, ability to model the model, meaningfully outperform those who aren't good at modeling the model. So this is this idea, right, that intelligence or capacity to solve problems, to answer questions with the help of AI shifts from who is smartest to who collaborates best with AI. So if we jump back here, you can actually see here in the paper, they have this, let me zoom in here, TOM signatures, right? So they have different ways of assessing the prompts that the participants used to understand if they actually were demonstrating good theory of mind for the model. Just some quick examples here that you can see in the paper. Things like prompts scored higher for theory of mind in situations where the users ask things like clarifying questions. They're asking clarifying questions or reasoning. They're not just looking for direct answers. They supply missing context instead of just assuming that the model knows what they're on about. They're checking or challenging responses consistently. They're adjusting instructions based on what the AI said along the way, and they're explicitly setting goals or strategy. Low scores came from copy pasta, treating AI like Google, assuming shared context, and giving vague or irrelevant instructions. So what does this mean? What does this mean in practice? Okay, so how has this changed how I interact with language models? I've simplified those things to just give a few very specific starting point examples, right? So number one is ask better questions. This seems obvious, but it's not obvious. You need to be asking better questions. Force assumptions and counterfactual, so we all have biases. It's good to use the model to explore the space of your potential biases to surface hidden assumptions that you have. This is a really good way to try and expose gaps in your thinking and really dig to find where the biases and assumptions are that you have. The third is to always treat answers as drafts. Okay, so this should be an ongoing process. If you're digging into a gnarly subject or a complex topic, then the responses shouldn't be treated as one-shot golden results, right? Everything should be an ongoing draft that's continually revised and updated, and the deeper you go, the more context you provide, the better questions you ask, the better and more refined the responses become, but never treat the output as the end goal, in most cases. And then the last one is basically kind of you could think of this more as the basket that all the other things go into, right? Clarify your thinking, use it as a tool to enhance your thinking, rather than using it as a replacement for your thinking. The big problem or the trap that we're all falling into is really outsourcing. There's an incentive to outsource your thinking to these models and to just think they can do the work for you, but that's not how it works. You need to use it as a grappling partner.